So you would go two-tailed alpha equals 0.01, and you would just, go down and be like, oh, hey, there it is, using your degrees of freedom, which you should know for that information. So then again, if your t is greater than your t critical, you reject the null hypothesis. If it's not, you fail to reject the null hypothesis. So then they're going to ask you, well, what if you use your repeated measures ANOVA with alpha equals 0.01, blah, blah, blah. This is really fun. I mean, this is basically what we've been doing, and gosh, it's just so long. So they want you to find your between treatments, your within, they don't give you anything. What I did is I calculated the between, because there is an equation for it. I don't know if you want it, but, well, it's pretty easy for this one because there's only two whatevers. Anyway, you are going to do t, the sum of t squared over n. If you don't, minus g squared over capital N. If you don't want to do that, it's fine. That's the equation. So, like, number-wise, I'll just do the numbers for you if that was confusing. So to calculate your between treatments, you would do 3, because that's the t of the first column. So t is just, you add every number in a column. So treatment 1, the t for treatment 1 is 3. The t for treatment 2 is 30. So you would have two t's, you would have 3 and 30, and you would say 3 squared over 4, because that's your n, plus 30 squared over 4, minus g squared over n, capital N. And so g squared is just all of the x's added together, so that would be 33. So 33 squared divided by all of the n's, so that would be 8. Oh, maybe that's what, oh, nope. Anyway, so then you would do that math and find your SS between. To find your SS within, yeah, it's really hard. I wouldn't want to do, it's not that hard. You find the sum of squares for both treatments and then you add them together, but I just am so lazy, I don't want to do that. I ended up just doing the sum of squares total, which again is the sum of x squared minus g squared over n. So hopefully you should be able to do that, come up with an answer, and then you're going to subtract your between treatments from your total to find your within treatments. Once you've done that, you can start doing your sum of squares between subjects, which again is the sum of p squared over k minus g squared over n. So p, again, is you add rows. So you'd have 11, 12, 7, and 3 as your p-values. And remember, you square them, you put them over k, which in this case is 2, and then you subtract g squared over capital N. Capital N, capital N. And that should be your sum of squares between subjects. And once you find your sum of squares between subjects, you subtract that from your within treatments to find your sum of squares error. Lovely. Now, to find your degrees of freedom between treatments, you would say k minus 1. Oh, whoa. Your degrees of freedom is 1. That's what bothers me, is you have this huge, huge MS for your between treatments, and that's, I don't know, I might have done that wrong. I don't know. The formula for degrees of freedom for between treatments is k minus 1. K minus 1. And so then within, of course, is capital N minus k, so that's 8. Oh. Yeah, capital N minus k. So that's 8 minus 2, which is 6. So, yep. And then your between subjects is little n minus 1, so that's 4 minus 1, and then your error is, 6 minus 3 is 3. I mean, like, again, I don't know necessarily what the formula for error is, but it's within treatments minus your between subjects. So, yep. And then your total is just capital N minus 1. So once you have all of your degrees of freedom, you can go ahead and find your MS between treatments, which is the exact same as your sum of squares between treatments, unless you found a different degrees of freedom, which is good, I think, because I don't know, I don't know. And so then, to find your MS of error, you would just do your sum of squares error divided by your degrees of freedom error, and that's your MS error. And then to find F, you just do your MS between treatments divided by your MS error. Okay, to find the F critical value, you go back to the F distribution table, and since again alpha is 0.01, you're going to look at the bold number. On the left, you're going to use your error degrees of freedom this time, so that would be 3, and your top number is just 1, or you know, whatever degrees of freedom between you found between treatments. And then if you know F is bigger, reject. F is smaller, don't reject. Alright, so that's number 3. Number 4 is yet another semi-completed table. So, again, best thing to do is just find the degrees of freedom. So, to find degrees of freedom between, it's different in this one. Because what you're dealing with is a 2-factor, it's like a, it's a 2-factor study with 3 levels of factor A and 3 levels of factor B. So, if you remember, you might not, that's totally fine. Mr. Koch drew this square. It was like a window square, like it had a square and it had like 2 lines, so it was like, you know, 1, 2, 3, 4 boxes. What they're doing is they're saying that they have three levels of A and 3 levels of B. So you're going to have a total of 9 little boxes. It might help to draw this out. That's what I did. So anyway, to find your between, you're going to subtract the number of boxes from, or you're going to subtract 1 from the number of boxes. So the number of boxes are basically your K, because they're all the different, like, treatment conditions, if that makes sense. So basically it's going to be 9 minus 1, so 8 should be your degrees of freedom for between treatments. And then to find factor A, you take your levels of factor A minus 1. So there's 3 levels of factor A, minus 1 is 2. Same for factor B, you take your levels of factor B and you subtract 1 from them. Since you have the same levels of factor A and the same levels of factor B, you should have the same degrees of freedom for both of them. To find your A-B interaction, again, you just subtract factor A, factor B, factor A and factor B from your between treatments, and that's your degrees of freedom for your A-B interaction. To find your within, oh gosh, you take the degrees of freedom in each box and add them together. So in each box, they're saying that there are a sample of 9 participants. So if n equals 9, your degrees of freedom is going to equal 8, and you have 9 boxes. So I'll let you do the math, but your degrees of freedom is going to be the degrees of freedom found in each box added together. So then your total is just capital N minus 1, and capital N is all of the n's times however many boxes you have. So, yep. And I know that I'm talking in boxes because this is it's just really confusing for me. So if you drew out the box, I really hope you did. It'll make a lot of sense because you're like, oh yeah, there's like 9 boxes here. If there's not 9 boxes, you should recount. Anyway, thankfully, now that you have these beautiful, beautiful degrees of freedom, well, you can, well, right off the bat, you can figure out what your within treatments sum of squares is, because they give you the total and they give you the between. So just subtract the between from the between treatments from the total. 360 minus 144 is going to equal your within treatments. So that's just great right away. And then to find your sum of squares for A, since they give you the MS for factor A, you can just do your MS times your degrees of freedom to find your a, because sum of squares divided by degrees of freedom equals ms, like we were doing before with the algebra. So hopefully you remember that. Hopefully that makes sense. If it doesn't make sense, that sucks. Okay. Alright, and so then to find the next one is a little confusing. Because your f for your AB interaction f, the formula for that is AB, your ms for your AB interaction divided by within. So that means that if you multiply your f by your within, it should give you your ms for your AB interaction. So once you've done that and you find that number, you can multiply that by the degrees of freedom for your AB, and that will give you your sum of squares for AB. So that's convenient. And once you figure that out, then you can just add your AB and your A and subtract that from your between treatments, and that will equal your factor B sum of squares. And then once you find your factor B sum of squares, you can just divide that by your degrees of freedom, and that'll equal the ms for that, right? And then once you have all of your ms's, to find the f's in these problems, the ones with the factors a, b, and the AB interaction, it's always going to be your factor divided by within, your ms within. So to find your f for factor A, it would just be your 18 divided by 3. And so you just keep going down. So factor B would be MSB over 3, and AB interaction would be MSAB over 3, which you don't need to find because they already gave it to you. So that is problem 4. It's not too difficult once you figure out the relationships between the tables. Alright, so the last one, number 5, is a little intimidating because it's that's a lot of numbers. And actually, might have done this one wrong too. I'm not sure, but I was just my sum of squares were just so big. Some of them were so big, and some of them were so small. So again, sum of squares between. This time it's a little confusing to do the formula. So I mean, if you don't want to do the formula that I used, you don't have to. But I did. I took. So, see how they give you all the t's in all of those? I added the t's, so for Roman numeral 1, I added, t equals 4 and t equals 7 to find t equals, I can't even do that in my head, what is it, 7, 8, 9, 10, 11, 11. So, 11 squared over 6, because that's the n I was using, because when you're taking both male and female, you have to, add the n's, and that equals 6. So t squared over n, the sum of t squared over n, minus g squared over capital N, and that's how you find your between